Good morning, my YouTube viewers. It is Crystal here, and in this video what we're going to do is we're going to discuss contour plots in R. And I think there's going to be three types of contour plots that we're going to discuss in this video. So a contour plot is a geographical representation of three-dimensional data in 2 dimensions using contour lines. So what we're going to do is we're going to create a contour plot in R. And then we're going to create the contour plot in R to show you what a contour plot looks like and how you can make one. So the first thing we're going to do is we're going to define the grid for X and Y. So X becomes SEQ brackets negative pi, length equals 50. Y becomes SEQ brackets negative pi, length equals 50. So X and Y values are the same. And then we're going to compute the z values for the function cosine x plus sine y. So z becomes outer brackets x, y, function brackets x, y brackets cosine x plus sine y. And then now that we've got the x, y, and z variables, we're going to define the contour plot. So contour brackets x, y, z, main equals contour plot of cosine x and sine y, x lab, that's your x label, equals x, y lab, that's your y label, equals y, n levels equals 20, col equals topo.colors, brackets of 20, and then brackets. And then so we're going to run that. And then when we run it, this is what we get. So it's got 20 levels of this contour plot. So that's one contour plot that you can make. The next type of contour plot you can make in R is a field contour plot. It's similar to a contour plot. Instead of drawing contour lines, it fills the spaces between the lines with colors to represent different ranges of values, making it easier to visualize gradients and regions of equal value. So again, what we're going to do is we're going to define our x and our y and our z variables. So x becomes SEQ brackets negative pi, length equals 50, which is the same as the earlier program. And y becomes SEQ brackets negative pi, length equals 50 brackets. And then z becomes outer brackets x, y, function brackets x, y brackets cos, that's cosine, brackets x plus sine brackets y. And then we're going to use the x, y, and z variables to create a field contour plot. So field.contour brackets x, y, z, color.palette equals topo.colors, in levels equals 20, main equals field contour plot of cosine x plus sine y, x lab is x and y lab is y. And so we have the field contour plot. It looks a little bit different from the contour plot. Personally, I think it is a little bit easier to read than the contour plot. And the reason why is because it gives you a legend on the right hand side. So the negative 2 is a blue and the positive 2 is 1. So as the numbers increase, the value becomes warmer. So the next contour plot we have It's a contour and image combination plot. It's a visualization where a raster image, usually a heat map, is displayed and contoured lines are drawn off of it to highlight the levels or gradients in the underlying data. So again, we're going to create our X, Y, and Z data. So X becomes SEQ brackets -2, comma, -2, comma, length equals 50. Y becomes SEQ brackets -2, comma, 2, comma, length equals 50. And Z equals or becomes outer brackets X, comma, Y, comma, function brackets A, comma, B, EXP brackets -a squared plus b squared. And then we're going to draw the image. So image brackets X, comma, Y, comma, Z, comma, main equals contour and image combination. Col equals terrain dot colors 20. And then we're going to overlay contour lines of contour brackets X, comma, Y, comma, Z, comma, add equals true. And this is your contour image. And you can see that the contour image is a circle, and in the previous examples we used pi, and in this one we're going to use circles. So what I want to do is I just want to see what's going to happen if we do this in pi. Let's see what happens. It's running the cell. It's just taking a little while to run it. It's just being a little bit awkward at the moment. Well, it's not allowing me to collect to the runtime, which is a shame because I'm doing this on Google Colab, and it's not allowing me to do it. Well, it's a shame though. I'm having some problems with Google Colab saving, and because I'm having problems with Google Colab saving, it's not allowing me to do this next piece of code because it's trying to save, and then it gives me a message saying it's not able to connect to the runtime. But we'll see what happens. And then if it still won't save, then I won't be able to do the next one, which is a shame because that's what I wanted to do. Okay, I'm afraid I'm not going to be able to show you this one, which is what I wanted to do. So I'm going to go, oh, it saved it. So it's successfully saved. So let's see what's happening now that it's successfully saved. Maybe I will be able to do it. Try it again. Okay, so I'm going to have to stop this video. It won't allow me to do it, which is a shame. I wanted to do it in Pi, and I couldn't do it in Pi, but you were still able to see it. And obviously, when I resaved my work, it lost all the images as well. So that's going to be another problem that I'm going to have to work on. So I'm going to work on this problem, see if I can get it running again. And so I'm going to make another video on visualizations in R. And I hope that you decide to watch that as well. And thank you for watching.